Hi guys, welcome to the next lesson. And in this lesson, we're going to talk about solving quadratics. So the first thing that you need to know is what is a quadratic equation? Well, hopefully you have seen this by now. Where A, B, and C are, that's what's part of like the quadratic formula and things like that. So A is the coefficient of x squared, B is the coefficient of x, and C is your constant. So you've probably talked about different ways to solve it. So think back to all the different ways. So you could factor this part and solve. You could solve by using square root. You could solve by completing the square. Or you could solve by, as I mentioned before, using the quadratic equation. So all these things are totally okay. It's just kind of depending on what information you have, which one you want to choose to use. You probably also talked about the zero product property. So let's pretend that I was able to factor, and I got x minus 3 times x plus 2. So what the zero product property says is that if I set this equal to 0, the whole thing is 0. And likewise, if I set this equal to 0, the whole thing is 0. So I use this property to be able to do my last step in my equation and actually solve for the quadratic. So we're going to take this piece, x minus 3 equals, and set it equal to 0, and then x plus 2 and equal 0. So my final answer in this case would be x equals 3 and x equals negative 2. So sometimes they're not as easy as just that. So if I have like 2x minus 7 and then 5x plus 1, that's where it's really imperative that you set it equal to 0. So 2x minus 7 equals 0. I'm going to move that 7 over. 2x equals 7. So x equals 7/2. So just make sure that you're going through that process and really truly setting it equal to 0. Okay, so we are going to start off with the first one and solve by factoring. So the first thing that you're going to do anytime is, like we talked about before, is to factor out a GCF. So the first thing I notice about this is that they have a 2x in common. So if I factor out a 2x, I'll have x minus 7 left over. And then I'm going to pull from that zero product property. So I'm going to set this equal to 0 and this equal to 0. So 2x equals 0, x minus 7 equals 0. So here, if I divide by 2, or any coefficient for that matter, it's just going to give me 0. So you can kind of keep that in mind. When there's not a plus or minus on the outside, it's just going to be 0. And this is x equals 7. Another thing to keep in mind when you are solving is almost all the time you're going to want to set this equal to 0. So I'm going to go ahead and move this over and then find the GCF. And so I have, let's see, 4x squared minus 25 equals 0. Okay, well, this is a special binomial. So I can notice I can take the square root of this and the square root of this, and it's connected with a negative sign or a minus. And so these are one of those difference of squares. So this is 2x plus 5, 2x minus 5. And so now I have 3 pieces I'm going to set equal to 0. 1, 2, 3. Okay, so go ahead and solve for each of those. Okay, so you should have gotten x equals 0, x equals negative 5/2, x equals positive 5/2. Okay, and then so finally, we're introduced to 3 terms. And so I don't care what you have. First thing, factor out a GCF. So let's do that first. So x squared minus 3x plus 2. And then you learned different ways to factor trinomials. So I like the AC method. If you use like the Mark method or whatever, just you do what you're most comfortable with. So what you're going to do is multiply the first and the last terms together always. So that's going to be 2. And I need 2 factors of 2 that add, right here, this is going to tell me that add to give me 3. And I know this is negative. That's going to come into play later. So let's see, 2 factors of 2 that add to give me 3. Well, 2 and 1, 2 times 1 is 2, 2 plus 1 is 3. So I have it. So the reason I'm doing this is I'm taking this middle term and I'm breaking it into 2 pieces. So instead of having negative 3x, I'm going to have negative 2x minus 1x. So notice that this is the exact same thing as this. It's just going to look different. So I'm going to rewrite it as 2, and then I have x squared minus 2x minus x, or 1x, plus 2. Okay, and then I'm going to simplify that. So we're going to do that using factor by grouping. So I'm going to group this and group this. So I can factor out, really, I don't care about this 2 because I can divide both sides by 2 because we're solving. So I'm just going to focus on this part. So what do these 2 have in common? They have a GCF of x, and I'm left with x minus 2. I want this one to look like these 2 binomials that I just created, x minus 2. So I need to figure out what I must factor out. Well, the only difference between this and this is the signs. So if everything is the same except the signs, I'm just going to factor out minus 1. Okay, then finally, we're going to regroup them as x minus 1 times x minus 2. And so then my last step is I'm going to set each of them equal to 0 and solve for x. So for this one, I'm going to have x equals 1. And for this one, I'm going to have x equals 2. And those are my final answers. Okay, then you learned how to do the square root method. So the first thing I want to do is isolate that square root as much as possible. So I'm going to, which means like get that square root by itself. So I'm just going to keep doing things until I get that, not square root, sorry, the squared by itself. So I'm going to keep doing things until I get there. So now I have x squared equals 10. And I'm going to take the square root of both sides. And when I do that, that's going to give me that x. Do not forget, when you take the square root of both sides, you have to include the positive and negative root of that. And that is it. Okay, so this one, notice like I have that squared by itself. I can't do anything inside the parentheses. So I'm going to start right here and take the square root. So these cancel out to a minus 3 equals plus or minus, and then the square root of 16 is 4. So I'm going to add 3 to both sides. Go ahead and put it in front of the plus or minus. So 3 plus or minus 4. So you need to make sure that you understand this plus or minus. So that means that there's 2 answers. There's 3 plus 4, oops, and there's 3 minus 4. So 3 plus 4 is 7, 3 minus 4 is negative 1. So these are your 2 solutions. Okay, and this last one, just like this one, I'm going to get the x squared by itself. So I'm going to subtract 5. Divide by 2, and I get x squared equals negative 25. When I take the square root of this, be really careful because I'm going to have a plus or minus, but this negative has to come out as an I, and the 25 comes out as a 5. So my final answer is x equals plus or minus 5i. Okay, and the next one we talked about, the next method is completing the square. And so this one, what you're doing is you're forcing it into a perfect square trinomial so that it looks like this. So let me show you how this works. So I'm going to move this 40 over because I don't want it. So I have n squared minus 18n plus something. So I want a special number there. I just don't want it to be 40. And so whatever I do on this side, I have to do on this side. So that's why I'm going to set that up. This is always plus, and I'll explain that later. Okay, so the formula to get this number is I'm going to take whatever this is, which, well, I'll just go ahead and use a number here. So 18, and I'm going to divide it by 2, and I'm going to square it. So 18 divided by 2 is 9. 9 squared is 81. So the formula for this is I'm going to take b, ax squared plus bx plus c. I'm going to take b divided by 2 and square it. So the special number that I want is 81. So whatever I do to this side, I'm going to have to do to that side. Because I found the special number, it becomes a perfect square trinomial so that I'm able to square it. So this is going to be the square root of this is n, the square root of this is 9, and it's always connected with whatever sign this is. So n minus 9 squared equals, and then we're just going to add these together, 121. Oh, gosh. Okay, and the reason why this works is because let's kind of go backwards. So if I said n minus 9 squared, we would have n squared and then minus 18n plus 81, because I don't care if this is a plus or a minus, that last term is always going to be positive because it's the same sign. So that's where we're getting that, and that's why we can go backwards here. So from here, I'm just going to take the square root of both sides, and I get n minus 9 equals plus or minus 11. I'm just going to add 9 to both sides. So n equals 9 plus or minus 11. So remember, we need to take this in two different pieces. So 9 plus 11 is 20. 9 minus 11 is negative 2. Okay, and for our last problem, the first thing that I notice here is the numbers are really big. So I see that, let's see, what can go into everything? Can 4 go into everything? Can 8 go into everything? 8 can go into everything. So x squared plus 2x, and then equals 6 times 8 is 48, 6. Okay, so let's practice completing the square. So I've got this. I need to add a special number to both sides. And so let's see how we get there. So 2 divided by 2 squared. So 2 divided by 2 is 1. 1 squared is 1. So when I do that, then I can simplify this into x plus 1 squared equals 7. And I'm going to take the square root of both sides, and I get x plus 1 equals plus or minus the square root of 7. So I'm going to subtract 1, and I get x equals negative 1 plus or minus the square root of 7. We're going to have to keep it like this because we cannot combine negative 1 and the square root of 7. And that is